All right. So the first part of today's workshop was to try out Bolt 12 offers through Core Lightning. So as discussed in our previous workshops, I guess we all know how to set up a Core Lightning node and run the startup reg test shell script. So I've already, for those of you who are new joinees, it's inside this repository contrib startup regstash.sh. So when you install the Core Lightning software, this is where you can run the shell script to host your nodes on your local machine. So this shell script lets you host up n number of nodes on your local computer, and you can make them interact on the same laptop, so you won't need to set up different machines for different nodes. Just for testing purposes, we don't use mainnet here, we use regtest here. So I've already started this script. So after that, there's this command called start ln. So when you run start ln, it automatically starts your Bitcoin core in on the regtest network, and then it hosts up two Lightning node on your same on your computer. The first one is called L1 CLI, and the second one is called L2 CLI. To run commands to the first one, you do L1 CLI get info or any RPC command that you want. So this one's the first Lightning node that is hosted on this computer, and this is the node ID of this particular node. As you can see, it's hosted on the local host. This is the local host IP address. Uh, if I run the second node, as you can see, this is the L2 CLI, and this is the node ID of the second node. It's different from the first one. The first one is 02811. This one's 025B9. So these are two different nodes. So to to initiate payments between two nodes, you need to create some payment channel between them. It could either be direct payment channel, or you could route it through the network indirectly through some of your peers, as many of you would already know. So in our case, we have two nodes. So we'll directly create a payment channel between L1 and L2, and we'll create a Bolt 12 offer from L1, and uh, we'll pay that offer multiple times through the second node. Uh, as a homework, as an assignment, you guys can host up 4 or 5 nodes using this shell script, and then try routing the payment through the network. It's trivial. There's nothing complex that you have to do. You will just have to create 5 nodes. So for that, you will have to run start ln pace 5. That would host 5 nodes on your local machine, and then you can access each one of them through L1, L2, L3, L4, L5. So to fund the nodes, to fund all the nodes linearly using this script, you have to run the command fund nodes. So yeah, so I've once you hit the command, it would automatically create a channel. As you can see, funding channel node 1 to node 2, waiting for confirmation. So the funding transaction has been mined on the blockchain. So now if I run L1 CLI list peers, we'll see this is the peer ID of L2. So L1 has a peer which has a node ID this, and it is connected to it right now. Number of channels, we have one. We can have multiple channels between two nodes, 1, 2, 3, 4, whatever you want. So right now we have one channel between L1 L2. This is the IP
So this
address.
ID is the node ID of L2, right?
Yes.
Uh,
Wait. L2 CLI get info. So as you can see, this is the node ID of L2, 025P9, 025P9. So now we have a channel between L1 and L2. So now we'll create a Bolt 12 invoice from L1. So we would use offers RPC followed by the amount that you want to inscribe in the invoice. We would be transacting 1,000 sats and then followed by the description. So let's test invoice. All right, so I might have made a typo. It's not offers, it's offer. Yeah. So as you can see, I created an offer of 1,000 sats using the first node. So as you can see, this is the bolt 12 parameter is followed by the invoice. So this one's the static invoice which the vendor can inscribe on their counter basically in the form of a QR code. So in Core Lightning currently, you can't directly pay a Lightning offer. You would have to fetch invoice manually. So we'll do that. But in wallets, which in like modern wallets, which are more user oriented and whose UX is a bit easier, you would just scan this the QR code belonging to this string, and it would automatically fetch invoice and pay it. So through L2, I would fetch invoice. Fetch invoice is an RPC to fetch the LNI string, which we discussed in the last workshop. So here L2 scans the QR code basically, and it runs the RPC fetch invoice. Yeah, so it communicates with L1, and this is the invoice that is fetched using the offer. As you can see, it starts from LNI. So it's an invoice. Now L2 can directly pay this invoice, L2 pay, and you just copy paste this. See, it says the destination is the destination node ID, the payment hash here, 1,000 sats. This is the payment pre-image, and the status says complete. Now, like till now, there's no difference between a Bolt 12 and a Bolt 11 invoice because we have just used it once. Now let's pay it multiple times. So what we'll do is we'll again run L2 CLI. Fetch invoice followed by the bolt 12 offer, the static offer that we made. So it fetched an invoice, and this invoice would be completely different from the one that we fetched before. As you can see, earlier one was L9-1QQGTX. It ends with VGA5. This one ends with JDYX. So this one is different from that one. So now if I pay this one, it says the payment is completed, and the payment pre-image would also be different. It says the payment pre-image is AE449, and the last invoice that we paid, the payment pre-image was 6D7F. So these are totally different. If I paid the same invoice, imagine if I pay this particular invoice again, the payment would obviously go through. Let's try this out. So I copy pasted the same invoice, and we are paying the same invoice again, which is not a good idea. You should definitely not do that. As you can see, the payment pre-image AE449 is same. So basically, if you use the same invoice again and again, in our case, there are just two nodes. We are paying L1 from L2, but imagine if we are routing a payment through the network. We have like 5 nodes: L1, L2, L3, L4, L5. So if I routed a payment from L1 to L5 using the channels with L2, L3, L4, the first time we pay an invoice, they wouldn't know the payment, the pre-image of the hash, the payment pre-image to grab the funds. If you guys know how HTLCs work, but the second time you pay the same invoice, they would know the payment pre-image before the vendor releasing it on the network, so they could steal your funds, and there's no way you can prevent that. So that is why it's not a good idea to use the same invoice again and again. But the thing with Bolt 12 is you can just scan this one here. Wait, this Bolt 12 and fetch multiple invoices using the same static offer and pay them again and again. So the vendor won't have to create new invoices upfront on the counter. They could inscribe this invoice on the product that they want to sell, and the user would run fetch invoice every time by scanning this, and the wallet would the user won't have to do this fetch invoice step. The user would just scan this and the wallet would internally fetch an invoice and pay it. So it's a very simple UX in that sense. But I hope you guys are able to appreciate the beauty of how uh, how Bolt 12 basically facilitates this. For Bolt 11, you would have to create invoice every time you pay someone. You can't use an invoice again. So those are not reusable. And there are just to revisit, there are multiple parameters that you can set inside the offers RPC. Wait, offer. All right, wait. Uh, what where is the RPC API reference? Offer. So as you can see, you can make an invoice as per your convenience. You can create a recurrence of payment like a Netflix subscription kind of an invoice, which sends an LNI in a particular period of time. So there are multiple features as well. So this is how Bolt 12 works in practically in core Lightning. And there are multiple wallets which has adopted Bolt 12. I guess HRF also uh, sent out a Bolt 12 invoice to donate them. So it's an static invoice. You can use it again and again to donate HRF. All right. So is there any question, doubt, or anything? Or can we move to the topic for today, that is blinding routing?
No questions from mine.
All right.
Yeah, simple question from mine. Can you share the script where you can be able to start up the Bitcoin node together with Lightning nodes?
All right. Okay. So to run a Lightning node on your system right now, the node that I'm running, the L1 and L2s are not production nodes. You won't be able to access the main net through this. This is Reg test, which is used by developers to test their code on Bitcoin, and this is inside. Yeah.
That's fine. I just want to be able to pin up a lot of nodes and be able to communicate with them the way you are doing.
Yeah. So you would have to clone the Lightning repository. Wait, I'll show you. The core, you would have to clone the core Lightning repository, which is this one. Wait, I'll share the GitHub link as well. This one. So you can clone it in your local computer, and you would have to follow the instructions of installation. Uh, and after installing, you just have to run this command. It's 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 a shell script if you know what it means.
All right.
Yeah.
All right.
When
Thank
you
you so
run
much.
this script, it would automatically spin up some nodes on your local computer.
Okay. Thank you.
Sure.
You will also have to run Bitcoin in Reg test in the background, right? For this to take effect.
Yeah, yeah. But it would automatically run it up. So if you have a look at the script here, the first thing that it does is start Bitcoin T. See, start Bitcoin D in the background. So you won't have to do it manually. It would do it, but if you do it, it won't matter. So if it's on, it would skip this part and go on to create your Lightning nodes. But if you just run this, it would automatically start your Bitcoin D in reg test.
Right, got it. Thanks.
All right.
Is that C Lightning or is LND repo?
This one's C Lightning.
Okay, C Lightning. Okay, thank you.
All right. So, moving on to the topic for today. All right. So we are going to discuss route blinding for Lightning Network. This is a proposal by T-Best. All right. Currently, what happened? So this one's going to be a theoretical class. Like the users have nothing to do with how this works, what's route blinding, and what's all. So this one's just a geeky nerd thing. If you are interested in how data is routed through the network, uh, this one would be appropriate for you. So basically, right now to route any message into the Lightning network, we use source-based onion routing, which is called Sphinx. So what happens is it's like the message is like an onion. So when you route an onion through the network, each node which gets the onion, it peels a layer and pass it over to the next node. So imagine if I route a payment from L1 to L5, uh, I hand over an onion to L2. L2 peels its layer and sees the next node ID that it has to redirect the onion to. That is L3. L3 peels another layer. L4 peels another layer, and it reaches L5. So this is what happens when you route a payment on the Lightning network currently. But this has a loophole. Every time, in this particular system, if you see the sender, the privacy of the sender is maintained. Like L4 won't know that L1 initiated this payment, but everyone in the route would know that this onion would be going to L5 because the node ID would be inscribed into the Bolt 11 invoice, right?
Okay,
So
I have a question, Aditya. So, in our example, we're considering that L1 is paying an invoice that has been generated by L4 and routing it via L2 and L3 and L4.
yeah.
Before this process starts, L4 will create a pre-image, hash it, and share the hash of that pre-image with L1, right?
No, not before that. That happens internally when the payment. So you pay the invoice. You pay some. You create an HTLC with L2. L2 creates an HTLC with L3, L3 with L4, L4 with L5, and then L5 releases the pre-image to L4. L4 then claims the money. Then L4 releases the pre-image to L3, L3 to L2, and L2 releases the pre-image to L1. And as soon as L1 gets the pre-image, the transaction, L1 can be assured that the transaction is confirmed and the money went through. If
Right.
it
So
if
the
L
hash of the key image is shared by L5 to L1, right? Only if the hash is with L1, when L1 gets the pre-image, the L1 will hash that pre-image and check it against the hash that L5 already shared with it, right?
No, there's some confusion. So when you pay an invoice, you don't have the pre-image to the payment to the hash that is presented inside the invoice. Once L5 gets the money from L4, it releases a pre-image to L4. L5
Right.
releases pre-image to L4, L4 to L3, L3 to L2, L2 to L1, and then L1 is sure that the payment went through. So the
Right.
pre-image goes after you pay the invoice.
Right, I agree with that. Okay, but to ensure that that pre-image is legitimate, right? Uh,
Yeah.
uh, what L5 does is L5 is the one that creates the pre-image, right?
Yes.
Okay, and
Yes.
after creating the pre-image, L5 hashes that pre-image and gives it to L1. right? And then L1 gives it to L2, L2 to L3, L3 to L4, L4 to L5. And then when L5 releases the pre-image to L4, the hash that the hash that L4 has received from L3, L4 will hash the pre-image given by N4
Yes.
and L5, sorry, and match it with the hash of that has been given to it by L3. And if they match, then the HTLC is unlocked, right?
Yes. Yes. Exactly.
Yes, that is what I wanted. Yeah, fine.
Exactly. That is what happens. So that is why it's not advised to use an invoice twice, because if you use the same invoice, it would have the same payment hash. And if any of the node in the network already knows the pre-image to the hash, they would just they won't redirect the payment to the node further, and they would just claim the money. So if if from a payment from L1 to L5, if L3 knows the pre-image, so L3 would automatically claim the money and L5 wouldn't get the money, and you would have paid the money that you were supposed to pay to L5 to L3. So that's
Right.
why invoices are not reusable. And so, yeah.
Yeah, fine.
Yeah, so Sphinx is basically an onion routing mechanism. Each node peels a layer of the onion, and in the peel, it's inscribed the address of the node that it is supposed to pass over the onion to. So in this particular system, if you can see, the privacy of L5, the privacy of the vendor is not sustained, because each node in the network would know that this one's going to L5, because if they have the access to the invoice. But in onion routing specifically, each node would only be aware of the node that the onion is coming from and where is it going to. They don't know the final destination or the initial destination, but the payer would know where it is sending the money. So imagine if you are a vendor and you don't want to expose your privacy and you want to accept payment anonymously. This is where route blinding comes in. So this one's gonna be heavy on cryptography. So all right, as you can see, this proposal is inside the bolts repository. This one's the main spec for the Lightning network. If you have any doubt regarding anything in Lightning, this is where you want to read about that to
Can
see
you
what.
zoom a little?
Sure.
Yeah, that's good.
All right. So what happens is, I'll show you a diagram. So the receiver, as you can see here, the sender, this is the sending node, and this is the receiver node which receives the payment. So the receiver don't want to expose their privacy. The vendor doesn't want to tell the sender who you're paying. So it creates a blinded route with a introductory node. The introductory node in this case is node 3. The first node in the blinded route is the introduction point. So the sender wouldn't know the node ID of the receiver or the node 4, or even the sender wouldn't even know how many nodes are there in the blinded path. There could be like 3, 4, 7 or n number of nodes in the blinding path, but the sender couldn't know this. So the sender would just create a normal source based routing to node 3, and then the blinding route would take over. The blinding route protocol would take over, and then the payment would go through the receiver. And each of the node inside the blinding route would not know the node ID of the receiver. They would just know where this particular packet came from and where am I supposed to hand it over to. They won't know the distance that is between the receiver and them. So here the node 4 would obviously know that it's passing over to this particular node 5, but node 4 is not sure if node 5 is the final destination of this packet, or is it going to redirect it to some other node. So it maintains the privacy of of the vendor that is receiving the payment. So how this happens is, uh, there is a flow in cryptography called elliptic curve Diffie-Hellman. It's called ECDH. Diffie-Hellman were the two scientists that developed this. So this particular algorithm helps two people to create a shared secret between them without revealing it to the third party over an unsecured channel. So imagine, okay, so this one, oh, okay, this one would have went through your heads. So imagine if me and Faisal wants to create uh, uh, create an encrypted channel between us. But currently, whatever message that I sent to Faisal is being seen by someone else. It's an unsecured channel. So whatever message I sent to Faisal would be uh, snipped by someone in between. So Diffie-Hellman algorithm helps us to create a shared secret over an unsecured channel. So even if the channel where we are uh, communicating is unsecured, someone is able to see all the messages that we are transacting. But by the end of the flow, we would have a secret key, which apart from me and Faisal, anyone else would not be able to guess or derive or do anything about. And then using the shared secret, we could encrypt and decrypt messages between us. So this is what happens. So, all right, the recipient then blinds each node and channel along that route with ECDH. So basically, what happens is the receiver in the in the in the payment flow, the receiver here creates a shared secret with every node inside the blinded route. In this case, node 3 and node 4. So the receiver would create a shared secret with these two nodes. All right, so let's see the notations. Some of you might be, if you guys have went through the Mastering Bitcoin book, you guys would know that there is a generator point on the elliptic curve, which is multiplied by a number to get the private key here. So as you can see, a node Ni is the node ID and Ki is the private key, which is multiplied by the generator point. So a generator point is a public point which is known by everyone. Private key is obviously private, which is known to the owner of the key, and the node ID, which we see, which we advertise as our alias on the network. So what we do is we create blinded node IDs. So these blinded node IDs are derived from node IDs, but those are not node IDs. So uh, each node in the network would see the blinded node IDs. They won't know which node are we transacting the onion to. So, and these blinding node IDs are a random anonymous number. So you wouldn't dox your identity on the network if you use it. And there's this ephemeral keys. The name ephemeral is used because these are used only once during the flow, and these are not reused.
Hey, K of I is your private key. Okay, the small b, what is it? Is it another nonce, just a random random number that we choose, random scalar?
No, this is the blinding factor. If we choose a random number, that would be a different node ID, right? This blinded node ID is generated from your node ID, but it's not your node ID. So you're not doxing your real identity. This is your blinded identity. We'll look at how it is derived here in a moment.
All right.
Yeah. So as you can see, the requirements of route blinding is intermediate nodes in the blinding route must not learn the node ID or the SCID. SCID is the short channel ID of other intermediate nodes except for their immediate predecessor or successor. So every node inside the node ID wouldn't know what's the initiating node ID or the final receiving endpoint. It would just know where this onion came from and where am I supposed to send it to. Intermediate nodes must not learn their distance to the recipient. So if I give you an example here, the node 4 won't know if it's redirecting the onion to the final receiver of it, or if it would be redirected further into the network. So no one here, N3 or N4, would be able to guess their distance from the final destination. Senders must not learn the real node ID or the short channel ID of the blinded intermediate hops after the introduction point. So the sender would not know any of the nodes or the short channel IDs, which identifies the channel that you have with a peer beyond node 3, because node 3 is the starting point of this blinded route. So the sender would just create a normal payment, normal Sphinx onion to N3, and then it won't know where's the onion going to or anything about the path per se. If NR here stands for the node number. So if the rth node create multiple blinded routes to itself, so if the receiver creates multiple routes like N3, N4, and then one more route with N5, N6, and you can create any number of blinded routes to yourself. Senders must not be able to tell that these routes lead to the same recipient. So looking at two blinded routes which goes on to the same recipient, you should not be able to guess if it's going to the same node, because then you would just dox your identity. Unless, of course, the layer above, which is the application, leaks it. So yeah, this is what happens. So each node in the blinded route, to each node, receiver would have a shared secret with them, and receiver would be giving them some encrypted data, which would only be which could only be decrypted by the node 3, or the receiver would know it. No one else could see what is inside the encrypted data. So this is how blinding routes are created. So all right. Here all the small letters are the private keys and all the big letters are the public keys. So the big letters, it's secure to share your public key with anyone, but it's not secure to share your private key with anyone. So the receiver node initializes an ephemeral key. As you can see, it's a 32-byte key. It's a private key. It derives the public key, which is known as the ephemeral public key. Now, for I is equals to 0 to R, it basically creates a shared secret with each node inside the blinded route. As you can see, SS here stands for the shared secret. So the shared secret is derived from the private ephemeral key multiplied by your node ID, multiplied by the node ID of the node that you're creating your shared secret with. And so this one, okay. So the receiver would know this, the private key that it has created, but the person that it is creating the shared secret with won't know this. It would only know the public ephemeral key. So on the receiver's node, it would calculate the shared secret using this. It would know the node ID of the person it's creating the shared secret with. So it would multiply it with the private ephemeral key and it would hash it. And the node which I'm willing to create the shared secret with would know the public ephemeral key and the private key to the node ID that it belongs to. Here the KI is the private key of the capital NI. So these two would be equal. Why these would be equal is NI is basically G multiplied by KI. As you can see here, NI is equals to G multiplied by KI. So substitute it here, EI into KI into G. This is what we are hashing. And EI is EI multiplied by G. So if I substitute it here, it would be KI into EI into G. So these two would be equal. So the hash would be equal. So that's how they create a shared secret. So no one between NR and NI would be able to create this secret. This is just between NI and NR, because any node except NR won't know the private ephemeral key, and any node except NI would not be able to get the KI, because it's your node, it's your node's private key. So that is how a shared secret is generated. If there's any doubt, feel free to interrupt me, because this is quite mathematical and confusing at first.
It's clear to me. Yeah, clear to me.
All right, great. Then using the shared secret, you create a blinded node ID. So you create the shared secret, and you derive the blinded node ID using something called HMAC. HMAC is it's basically uh, authenticated encryption key. So you create a key using the data called blinded node ID. This is just, you can just consider it as a password here, for this secret key. So you generate a secret key again, and you multiply it with your node ID. So you get your blinded node ID, which would be used in the blinded route. Then you create another key called row. This row key is used to encrypt data, which is inscribed inside the blinded route. And then you create ephemeral key for the next node, the I plus 1th node, basically. So if you look at it, node 3 would be able to create ephemeral keys for node 4, ephemeral public keys for node 4. This one's the private key, which is derived by only NR. The node 3 won't know the private ephemeral key of node 4, but it would be able to generate the public ephemeral key, using the shared secret and its own ephemeral public key. And then there's encrypted data which is sent to the node, which could only be decrypted using the row key here. So to use the blinded, if there's any doubt, please, I'm repeating myself again, please feel free to interrupt me. Okay, so to use the blinded route, senders need the following data. So the sender here, the sender, which is paying the invoice, would need the real node ID of the introductory point. In our case, it is node 3. The list of blinded node IDs. So the blinded node IDs, which are derived using the process that we have just described. And this is not the real identity. So the node, no, the sender wouldn't know if this node ID belongs to node 4, because it would just appear to them as a normal node ID, like any other node ID. So they are not doxing any identities. And the encrypted data for each node. Each node would have an encrypted data, which is encrypted using the row key. Here, the row key is derived from the shared secret, and the shared secret is derived from the ephemeral public key. All right. So to pay the invoice now, and this route blinding is used in Bolt 12 as well. So Bolt 12 has this feature to prevent, to basically maintain the privacy of the vendor. The payment node doesn't need to know who I am paying. It just need to know the introductory node that it is paying for a service or something. All right, so this is the flow here. The sender finds a route to the introductory point through the normal route finding algorithm that is used in Lightning, and then extends it with the blinded route. It then creates an onion for that whole route and includes E0 and encrypted data 0 in the onion payload for N0. And it creates encrypted data I for the onion payload of blinded node I. So when the introductory node receives the onion route, it would have the public ephemeral key. So using it, it could derive the shared secret and the row key. And using the row key, it would decrypt the data which is inscribed for it inside the onion payload, which is, by the way, created by the vendor. The sender obviously wouldn't know what's the encrypted data for each of the node in the path, and the encrypted data would then tell the particular node about where to send this onion to, and what's the public ephemeral key for that node is. So using the row key, it decrypts the encrypted data and discovers that B1 is actually N1. N1 is the real node ID and B1 is the blinded node ID. It then forwards the onion to N1 and includes E1, the ephemeral public key, in a TLV field in the lightning message. So TLV, as I guess we have covered this in the past in the past workshop, TLV is a serialization a scheme of serializing things into a message. Basically, it stands for type, length, and value. So you serialize the type first, and then the length of the thing that you're sending, and then the value of the data that you want to send. So then each node in the blinded route would derive their row key. It would decrypt the data, and then it would pass over the onion to the node that it is supposed to. So the each node would just know where the onion came from and where am I sending it to. It won't know the final destination. It won't know the distance up to which this particular onion is going to travel on the network. So no one would know the vendor here. Uh, and finally, receiving from blinding node. Finally, the receiving node could also inscribe some data for itself to recognize if this particular onion came from the same route that it is supposed to be. So if you read it here, when NR receives the onion message, and ER is the public ephemeral key which each node receives when it receives the onion. They do the same unwrapping as intermediate nodes. The difference is that the onion will be a final onion because receiving node would obviously know that I'm the final receiver of the payment. So NR must also validate that the blinded route was used in the context it was created for. So if I created a blinded route for payments, so it should not for a particular payment, it should not be used for some other cause, because obviously a blinded route can be used for anything. It's just a routing scheme, right? So it's important to note that anyone can create a valid blinded route to anyone else. But for example, Alice, for example, is able to create a blinded route between Bob, Carol, and Dave. In most cases, Dave wants to ignore messages that comes through routes that were created by someone else, because uh, anyone would be able to create a blinded route uh, using the algorithm that we have discussed just above. So in the final encrypted data that the user receives, they must have an authentication to validate that this particular blinded route was created by me. We'll discuss this in the upcoming section. So this here, the blinded payments, it's this particular scheme is inscribed into bold 12. So you can create blinded route in bold 12 in order to protect against malicious probing. All right, so this one talks about the attack vectors for blinded route. Uh, It is the recipient who choose what payment relay parameters would be used inside the route and encodes them in encrypted data. Obviously, so for each blinded node, the encrypted data would be generated by the vendor. Anyone else on the network wouldn't know what's inside this encrypted data. So this one talks about the data that the vendor inscribe inside the encrypted data field. Uh, so as you can see, when the onion comes to Bob, it would derive its row key, and then when it decrypts it, it would get these parameters uh, in the encrypted data, and it would know where to direct it to, because it also has the short channel ID. Uh, this one here, this talks about how do you set these fields up, the fee base MSAT or the proportional, because there are multiple nodes in the route and each one has different fee rates or whatever they charge for a payment. So these formulas could be used to derive what to set in these parameters. uh, yeah, as you can see, this one's the encrypted payload of Alice. Alice is the receiver of the payment. As you can see, it has the payment pre-image. This is Bob's encrypted payload. So as you can see, it is mentioned the outgoing channel ID. When Bob decrypts the data, it would know where to hand over this onion to. Similarly, Carol would also know where to hand over this onion to. So if Bob is passing over the onion to Carol, here the outgoing channel ID, this one here, would be the channel ID between Bob and Carol. So that is how Bob knows that it has to redirect the packet to Carol. Yeah, so this was a brief introduction to how blinding route works. If you have any doubt, you can feel free to ask any questions. Below this section, we have the attack vectors of how the sender node could probe the blinded route and make an estimate of what's the distance of the receiver. You guys can take it up as a homework to read it on your own and ask any questions if you have about this. So uh, if you look at it, if you look at blinding route blinding, this one is a different protocol from the native onion routing that is right now used in Lightning. The sender node does something different than what it does currently in the native system. Uh, the intermediate nodes in the blinding route also has some additional things to do, like deriving the row key and creating a shared secret and all of those things. And the receiver node obviously uh, creates the blinded route itself. So in each of the party, you would have to make some changes into the legacy system. So currently, route blinding. This article here talks about the adoption curve of blinding routes. So as you can see, LND. All right. So the most used implementation is obviously LND on the Lightning Network. It still doesn't support this feature. CLN offers support for manually constructing blinded paths via the command line. Uh, I haven't had a look at what are the RPCs to create the blinded route, but we can in the coming workshop uh, we can do a hands-on for creating a blinded route using Code Lightning. So yeah, this is an upcoming thing in Lightning, which is cool. So that is why I thought of covering it. So once this gets into the protocol, each vendor could privately create an invoice, and the sender wouldn't know who is it talking to, and not just for payments, but for anything. If you want to communicate with someone on the network, and you don't want to tell them about your identity, you can use a blinded route to redirect the messages or to receive the messages, and the sender wouldn't know who is it communicating to. It would just know the introductory node that we are talking to. Yeah, so this was a brief introduction to blinded paths. If you have any doubt, feel free to ask questions.
I had two questions. The first was about offers. Okay, so we created an offer
Mhm.
between two nodes, right? The interaction was between two nodes. L1, L2 created an offer and L1 paid it.
Yes.
Okay.
Yes.
Now if we have three or four nodes, okay, and let's say it's L1, L2, L3, and L4. L4 creates an offer. L1 wants to pay that offer via L2 and L3. Okay. So right
Yeah.
now what we are doing is we were fetching invoice, right? L1 was fetching that invoice and then paying it, right? So
Yeah.
how does the mechanism go about if it's routed through L1 to L2 to L3 to L4, like how does the fetching mechanism go?
All right. So what happens is when you pay an invoice, the invoice has the node ID of the receiver, right? So, and there is this gossip protocol inside Lightning Network. So when you connect to a Lightning node, it sends you some messages which are called the channel announcement message. Uh, there are three messages. I would have to look at what are those called. So basically, the gossip protocol here, the seventh bolt 7 is about channel
Okay.
discovery. So the
Announcement message, update message, and then
yeah.
one handshake message or something like
Yeah.
that.
So these messages helps you to create a view of the network, that which node is connected to which one, do they have a channel or not. So when you pay an invoice, your node basically tries to generate a path from your node to the receiving node using algorithms which are already legacy algorithms in computer science, like BFS, DFS, or if someone has read the graph theory in their coding classes. So that's legacy thing. It happens all over the internet. It's not Lightning specific. So when you pay an invoice, you know the node ID of the receiver. Then you probe the network. Then you generate a yourself to the receiver through the network, and that is how then you create an onion and you send it over to the network. But in
Okay.
blinded route, you would just know the introductory node, and then there would be route hint parameter inside the invoice. So you just include it inside your onion, and after the introductory node ID, you wouldn't know where the packet is headed to. So you won't know the vendor.
Okay, so if L2 creates an L5 creates an offer and L1 wants to pay an offer, L1 will just fetch that invoice, okay, and pay it, and then it is the lightning the channel graph. Okay, so L1 knows the entire channel graph, and then the routing happens L1
Yes.
to L2, L2 to L3.
Yes.
Okay, but it's not that you have to fetch the invoice. Each node has to fetch the invoice. L2 does it, L3 does it. No, right? It's only L1 that fetches the invoice only once. Only the routing happens via the
Yeah.
intermediary nodes.
And there's one more advantage of blinded routes. So each node wouldn't know the entire view of the network, right? So there are some. Imagine if I host a Lightning node, you host a Lightning node, and we create we create a channel, and we are not connected to anyone else on the network. So so no one would know that there's this payment channel because this is just a TCP connection. So you could include private channels into blinded routes as well. So if I have a private channel with you, which is not announced on the network, so no one apart from you and me knows about this channel, and you have some public channels with some of the well-known nodes in the network. So I could create a blinded route with the introductory node ID of yours. I won't have to dox my node ID on the network, and then the blinded route you would automatically get the packet and you would know that this is for me and you would hand it over to me. So you could include private channels inside your blinded route as well, basically.
Right.
Yeah,
Okay. And one,
this couldn't be
yes.
done in the legacy Sphinx protocol because L1 wouldn't know if L3 has some private channel which goes to L5. So they would have to only include the channels which they know about, that is the public channel, not the private channels.
Right. And one question I had is about an alarming statistic that I read just now. If I understood it correctly,
Mhm.
are 91% of Lightning nodes running LND?
Yes,
Oh,
majority of majority of network is on LND because LND is more UX friendly, and it's better to host. This might people have different opinion about this, but from what I have heard or I have experienced, LND, if you want to just run a node to route payments, LND is better than any other implementation. And many of the big wallet applications use LND at its backend. Core Lightning released uh, its its library to host a Lightning node, which is called Green Light. quite recently, so it's not very well known yet, but it's being adopted at quite a fast pace. So yeah, majority of the network is LND right now.
I was under the impression that the client share on the Lightning network is very decentralized and very diversified. Like I was under the assumption like 20-25% or 30% is LND, 25-30 is CLN, then there's Eclair. Okay. So but now it's pretty similar to Bitcoin, right? One single client having 90% of the user share.
Yes, but can you elaborate how why are you comparing it with Bitcoin? In what sense?
No, as in more than 90% of the nodes,
Mhm.
Bitcoin nodes run Bitcoin Core, one single client. But I
Yes.
used to believe that that is not the case in Lightning Network. I used to believe that it's pretty diversified between Eclair and LND and CLN. But now I know it's like one-sided even in Lightning Network. Like in Bitcoin, more than 90% of the nodes run Bitcoin Core. Even in Lightning, more than 90% of the nodes run just LND. So that was an alarming statistic for me.
Yeah, that's true. I was also shocked when I saw this statistics. Like
Right.
I don't know why it's that because in terms of the data growth, I think and in terms of eating up your like CPU threads, CLN is way better than LND. But when you uh, look at the development ecosystem of LND uh, and the GUI of LND, RTL is not. For example, if you have heard of RTL, RTL is basically the GUI for a core Lightning node. So you can host up a core Lightning node, and when you connect it to RTL, you would be able to see a graphical user interface of your node, and you can
Got it.
use that GUI to run your node. You won't have to run any terminal APIs, RPC calls, or anything. So LND has a good ecosystem on of of applications layer above the core node. So that's
And
why I
LND still does not support Boltwell offers, right?
no, I don't think so. So CLN is the CLN is in general CLN is the first one to do any of the cool stuff that is proposed in the ecosystem. Uh, Others are late bloomers, but yeah, that's how it works.
Right.
LND, yeah, it doesn't have Bolt 12, but I guess the PR is almost ready and they might have merged it. They might have merged some part of it and they are also working on the PR storage backup as well. So yeah, they're late bloom. They're a bit late bloomers. And there are some, they, all right, so it's going on stream. Should I? All right, so there are some spec rules as well which LND doesn't follow. Like when you send an error message, your peer is supposed to force close the channel, but LND doesn't do that. So there are
Okay.
some things that LND doesn't do according to
Right.
this.
Hmm.
But those are very minor things. Like you can obviously do interoperability between LND, CLN, Eclair, and all of those things.
Cool. So you have anything in mind for next week's session?
All right. So help me decide. So do you want to? Uh, do people want to get into these technical things like blinded routes and things which are going behind the scenes, which are highly cryptographic in nature, or do we want to discuss discuss things which affect the end user more?
I'd be very excited and interested in going into more detail of uh, blinded routes. Like last session, we talked about offers, right? And this session, we actually created a dummy environment of two nodes and actually created an offer and paid an offer. So if we can do some hands-on practice on blinded routes, create a blinded route and make a route a payment using a blinded route. If we can do that using reg test, that will be like very cool, so that we can practically implement the theory that we've learned today.
Yeah, we can do that. CLN supports blinded route, although I would have to look at what are the RPCs and how does it do that. But yeah, that's doable. There's this upcoming thing in Lightning called Covenants, if you guys have heard of it. It's
Mhm.
Yeah, it's a big proposal. So we can cover covenants, but I would have to devote like a week or two of research to learn about uh, because they enable many, they solve many of the drawbacks of Lightning that are currently uh, persisting. So, for example, currently a Lightning database is like there's no limit to how much the database of a Lightning node could grow, but there are some proposals in covenants called APO, any prev out or opcat, which enables Lightning to limit the growth of a database. So that would be revolutionary uh, for Lightning, because if you can limit the database, you would know how much data you need to distribute in the network to create a resilient backup and all of those things. And there are many things which the covenants solve, but I would have to do my own research
Right.
to read
So
up.
how about this? Like, because we've already started with blinded routes, so we can complete blinded routes by creating using the terminal, creating blinded routes and paying over the blinded route. And
Mhm.
if you think you need more time, depending upon your schedule, to prepare for a session for the covenants, then we can do covenants as a bi-weekly session. Like we can skip 1 week if you like your schedule does not permit you to devote too much of time. We can take next Tuesday for blinded routes, hands-on blinded routes, and then we can skip the Tuesday after that, and the next Tuesday, the alternate Tuesday, we can keep a covenant. So like you get 2 weeks, and you can devote time according to your schedule and prepare for the session if that is what suits you.
Sure, that's doable. Or we can also cover splicing. That's
Yeah,
also, yeah, we can
yeah,
cover
yeah. We can do that.
liquidity adds or splice. So let's keep the upcoming workshop on splicing and then liquidity, and then we would take a break of 1 week and then do covenants. So covenants is I am also not I'm like barely even an amateur on covenants, so I would have to read many
Right.
things.
What about hands-on blinded routes?
Yeah, we can do that like just like we did today, right? Before the start
Okay,
of the new topic, we can.
right. 10-15 minutes for that, and then we move on to splicing.
Yeah. If any of you are like don't have the patience to wait for the covenants workshop and you want to read about what it is, this is the website. It's called covenants.info. It has all the proposals of all the flags which are going to be enabled.
Right. CTV and OpCat, these proposals we have discussed on multiple occasions on the
Mhm.
Monday sessions, tech sessions. So OpCat and OpCTV, those who attend Monday sessions regularly have at least an overview of what OpCat is, what it does, and what OpCTV is, and what it does.
Mhm. Great. So okay, so you guys are already familiar with it. Yeah, so I should have attended that session.
Uh,
All right.
Yeah, if you go to the newsletter, OpTech newsletter, no, you just search for that keyword OpCat, OpCTV. So all the articles they've covered on OpCat and OpCTV, we'll get
Mhm.
those articles. So
Yeah.
and they also have podcasts like yeah, the people who curate the OpTech newsletter, they have their own podcast where the developers and the contributors and the people who come up with these proposals where they come and have a discussion. So like
Mhm.
that could also be a very handy resource if you wanna brush up on OpCTV and OpCat.
Yeah. More than the op CTV and opcat, it's the use case which I find very fascinating. Like how are they using these different covenants to enable these things like the vault, the L2. We can also cover L2 basically if you guys want. So L2 is when Lightning first came, there was this paper called L2, and there's this another Lightning paper uh, proposed by the founders of LND, which is currently in practice. But L2 is a different. It basically solves the same problem as Lightning does, but it does things differently, and it's an upcoming thing. So like if APO, which is the any prev out, is enabled inside Bitcoin Core, Lightning would be changed drastically. Like many of the things that we see right now won't be uh, in L2. So we can cover
We've
L2.
covered L2 as well. We've covered L2 in an optic session. Like L2, what it does is that basically it's still possible for somebody to broadcast the revoke transaction, right? So
Yeah.
somebody can broadcast the revoke transaction, then your node will listen for it, and then your node will catch it and then penalize the broadcaster. What L2 does is that it obsoletes the revoke transaction, so you cannot broadcast the revoke transaction anymore.
Yeah. You
Yeah,
just
so
you
we
just
covered.
drop the latest state on chain.
Right, exactly.
Yeah. So we can, that's because we can change the input of a Bitcoin transaction using the APO, which is the any prev out.
Right. Cool.
Yeah.
Yeah. So we have a lot of interesting topics that we can cover in the coming weeks. For like next week, let's take up splicing and a hands-on blinded route payment.
Yeah.
And then from there we can decide what we want to do after that.
Cool.
Aditya, are you aware of this project called VLS Validating Lightning Signer?
It's a signer. Like I haven't gone deep into it, but from what I know, it's basically used to sign stuff. So you can connect it to your Lightning node. You would send something to it, and it would return back the signed signature of it. From what I know, it's a very layman description of it. I don't know what goes on behind the scenes. So
Okay, okay. So I was looking into it. Maybe I might require some of your help in understanding parts of it. So maybe if I have something concrete, I'll try to get back to you.
sure, no issues. I'll try as much as I can. All right, then this is what we were supposed to cover today. I hope you guys had fun and I was able to explain things because I'm assuming most of you won't have any background in cryptography or mathematics, but I hope you got an idea of what blinded routes is and how it does operate.
Yep. Like most of us who've done mastering Bitcoin know what elliptic curve cryptography is, and most of us who regularly attend the Monday sessions, have gone through what, at least theoretically and technically, gone through what blinded routes are. We've covered blinded routes on multiple occasions. We've covered what onion messages are. We've covered all of these things. So like everything was put together in this session. So yeah, like those who are regular in Bitshala Club activities, I'm sure leveraged a lot of value from the session.
Great. All right, we can wrap it up, I guess.
Yeah, thanks a lot, Aditya.
All right.
Good
Thank you
night.
for attending. I hope you guys have had fun.
Thank you. Thank you.
Bye.
Yes, good night. Bye. Take care, everyone.